How did medieval builders cope with winter while constructing castles? Their secrets are still shocking today. Now you will learn these secrets of history. Building a medieval castle is a titanic task that takes decades and the efforts of thousands of people. We are used to thinking that with the onset of cold weather, all work came to a standstill until spring, because frost, snow, and ice seem like insurmountable obstacles. But what if I told you that everything you believed was not true? The largest construction projects did not stop for a single day, defying nature itself. Medieval craftsmen possessed technologies and secrets that allowed them to continue building stone walls, even in the harshest winter months. It was a real battle with the elements, in which man used all his ingenuity. Watch the video to the end and you will learn how medieval builders managed to make mortar set in the cold, why they lit huge fires right on the site of future walls, and what was the main secret that allowed them to work in the warmth while a blizzard raged around them.
Lift it up. Watch your step there. Step lively. Get your bread nail here.
I'll take a loaf. Is it
I will
fresh?
reveal the most closely guarded secret of medieval construction. The success of winter construction depended not so much on the work on the walls as on the organization of life at their foot. A temporary town grew up around the future castle, a real hive of activity that did not fall asleep even in the most severe frosts. This town was a marvel of logistics and planning, existing according to its own strict laws. Not only masons and carpenters lived here, but also blacksmiths, coal miners, cooks, and many other craftsmen. Each of them played an irreplaceable role in the overall mechanism. The center of this settlement consisted of large covered workshops and heated barracks for workers. These buildings were erected first, even before the main work on the castle began. They became the heart of the construction site, where life bustled, protected from the elements.
Good thing we're in here where it's warm.
Here you go, lad. Keep walking.
Daily life was organized with military precision because the entire project depended on the health and strength of the workers. Meals were plentiful and high in calories to replenish the energy expended during hard work in the cold. The diet consisted mainly of bread, dried meat, beans, and thick hot soups. To maintain order, there was a set of rules that all residents of the temporary city had to follow. People were put in charge of distributing food, fuel, and tools. Any disputes were settled by the master builder, whose word was law. The most important task was to protect the dwellings from the cold. The barracks were built of wood, with all cracks carefully caulked with moss and tow. In the center of each dwelling was a hearth, the smoke from which escaped through an opening in the roof. This city was not just a gathering of people, but a complex social organism. Here people exchanged news, made deals, and even held modest celebrations on religious holidays. This helped to maintain morale in difficult conditions. Surprisingly, the creation of this temporary settlement was the most difficult stage. It was necessary to calculate in advance the required amount of supplies, tools, and people for the entire winter. Any mistake in planning could lead to a stoppage of work. This system allowed construction to continue uninterrupted, without wasting precious time. While some workers battled the frozen ground and stone, others prepared parts for future structures in the warmth of the workshops. This created a synergy that conquered winter. We are very interested in hearing your opinion. What do you think about how this organization of daily life affected labor productivity and the final result? Write about it in the comments and don't forget to subscribe to the channel. Are you ready to learn the truth about how building materials were extracted in winter in the Middle Ages? When the earth was frozen and turned to stone, it seemed that nature itself had declared war on the builders. The air was clear and crisp, axes rang louder than bells, and with each blow, the stone threw off sparks, as if mocking the people. But for medieval craftsmen, winter was not an enemy. It was simply a different state of the world that required different techniques. They knew that cold makes the earth hard, water expensive, and fire man's main ally. Quarrying stone during these months became a feat. When the rocks froze, they became many times denser than in summer. The blow of the hammer echoed with a ringing sound, as if it were striking metal rather than stone. The cracks ran in unpredictable lines, and one wrong move could ruin an entire block. Then one of the most amazing technologies of its time came to the rescue: fire drilling. This method was known to the ancient Romans, but in the Middle Ages it was perfected. Huge fires were lit on the surface of the rock, sometimes tens of feet long. The fire burned for hours until the surface was red hot. When the heat reached its peak, the workers abruptly doused the stone with cold water or threw snow on it. This caused a powerful thermal shock. The rock cracked with a thunderous roar. The cracks went deep inside, allowing the blocks to be easily separated with wedges and hammers. This process was dangerous. Sometimes pieces of stone flew several meters away, and steam from boiling water enveloped everything around, turning the quarry into a volcano-like scene. But it wasn't just the stone that required a special approach. Winter logging had its own strict rules and traditions. It was believed that trees felled in winter, when they had no sap, were stronger, drier, and took longer to rot. Therefore, large construction projects were planned for the cold season, while the forest was asleep. Lumberjacks chose old trees without cracks and cut them down with one precise blow so as not to damage the fibers. Sometimes the trunks were deliberately left in the snow for several weeks. This way the wood was hardened and dried more slowly. The main problem in winter was not extraction, but transportation. In summer, stones and logs could be floated down rivers, but in winter this route was cut off. Then sleds came into play. Simple, but incredibly effective. Unlike wheeled carts, they glided over the snow with almost no resistance. Frozen rivers and lakes turned into ideal roads on which multi-ton loads could be pulled. Sometimes, for particularly heavy blocks, wide sleds were made from solid tree trunks. Up to 24 oxen, the strongest and most enduring animals, were harnessed to such a team. Their breath turned into steam, and their steps into a dull rhythm that echoed across the icy expanse. To make the journey easier, the peasants watered the road, creating icy tracks. The cargo moved along them almost silently. The horses and oxen walked slowly but steadily, while the men pushed the sleds with crowbars and levers. A single stone block could weigh as much as a dozen people, and each movement was a victory. In forests where sleds could not pass, another trick was used. Special gutters were laid, narrow channels that were then filled with water. When the water froze, it formed a smooth, icy track. The logs literally slid along it, picking up speed and rolling down to the loading site. It was fast, safe, and required minimal effort. In winter, the work became harder and more dangerous. Tools froze in their hands, metal broke from the cold, and their breath turned to frost. To prevent the hammer from slipping, the handles were wrapped in leather or cloth, and gloves were made of coarse sheepskin. Workers wore boots with metal spikes to prevent them from falling on the ice. They wore woolen caps soaked in grease to keep them from getting wet. All this was not just clothing. It was equipment designed to combat the elements. Every day in the cold was a test. People knew that if they did not get the required amount of stone or cut down the necessary trees today, construction would stop. And a stoppage meant more than just a delay. It threatened the destruction of the entire village because a house without a roof would not survive the winter. Therefore, work continued from dawn to dusk, and sometimes even at night by torchlight. Every block of stone and every log obtained under such conditions was a real treasure. They were marked, listed, and monitored to ensure they were not lost during transportation. Sometimes, for particularly valuable cargo, separate bridges or platforms were built to prevent them from falling through the ice. Now imagine, all this titanic labor could have been undone by one question: how to mix mortar for masonry when water simply freezes in the cold? How could they build walls when the whole world around them was frozen? The answer to this question will change your perception of medieval technology, and that is what we will discuss next. What I am about to show you is banned in 12 countries. Just kidding. But the secret we are about to discuss was indeed one of the most closely guarded secrets of medieval stonemasons' guilds. We are talking about a technology for preparing mortar that not only did not freeze but also set better in the cold. The key component of any mortar was lime, which was obtained by burning limestone in special kilns. For winter work, a special method known as slaking with hot lime was used. It was a simple but ingenious chemical trick. Unlike the usual method where burnt lime was slaked with large amounts of water and left to mature for a long time, here they did things differently. Unslaked lime, fresh from the kiln, was brought to the construction site. Water was added to it immediately before mixing the mortar. The process of slaking lime is an exothermic reaction, meaning that it releases a huge amount of heat. The mixture of sand, quicklime, and water literally boiled, heating up to very high temperatures. This hot mortar was immediately delivered to the bricklayers. It was necessary to work with this mixture very quickly before it cooled down. The hot mortar, when applied to the masonry, transferred its heat to the stones. This heat was sufficient to start the carbonization process, the hardening of lime, even at sub-zero temperatures. Moreover, the heat from the mortar melted the ice and frost on the surface of the stones. This ensured perfect adhesion between the blocks and joints. Preparing hot mortar was an art that required experience and precise adherence to proportions. The craftsmen responsible for the mortar were among the most respected people on the construction site. The quality and strength of the entire future building depended on their work. This technology completely changed the rules of the game. It allowed the laying of walls to continue even in severe frosts. Thanks to this simple chemical secret, the construction of the castle could continue throughout the year without losing momentum. The secret of hot lime was lost over time and rediscovered by modern restorers. It shows how deep the practical knowledge of medieval craftsmen was. They understood the chemistry of materials on an intuitive, experiential level. What if I showed you a time machine? We can't do that, but we can look into the past and see how a seemingly impossible task was solved, digging a foundation pit in ground frozen to a depth of 1 meter. This was the first and most labor-intensive stage of winter construction. Using ordinary shovels and pickaxes was practically useless. The frozen ground was as hard as stone. Therefore, the builders used the same method as in quarries: fire.
Lift it up.
Large fires were lit around the perimeter of the future foundation. They were kept burning day and night so that the heat would penetrate deep into the ground. Under the influence of heat, the soil thawed layer by layer, becoming soft and pliable. As soon as the top layer thawed to a sufficient depth, the workers quickly removed the coals and began digging out the earth. They had to work quickly and without delay before the ground froze again. It was a real race against time and frost. The thawed soil was loaded onto stretchers or into boxes and carried away from the excavation site. Then the cycle was repeated again. Bonfires were lit at the bottom of the dug pit to warm the next layer of soil. This process was slow and required a huge amount of firewood. Entire teams were busy just delivering fuel and keeping the fires going. The smoke from these fires was visible for many kilometers, a sign of the feverish work going on. When the pit reached the required depth, an equally important stage began: laying the foundation. The bottom of the pit was heated again to remove any remaining ice. The first row of foundation stones was laid directly on the warm ground. A hot mortar was also used for laying the foundation. It not only bound the stones together, but also additionally warmed the base. This ensured the monolithicity and strength of the entire structure. After completing the work below ground level, the builders gained a huge advantage. The foundation, laid in winter, underwent natural settlement in the spring, along with the thawing soil. This made it even more stable and reliable. What other difficulties besides the hardness of the soil do you think the workers encountered when digging the foundation pit in winter? In the next chapter, you will learn how they managed to lift multi-ton blocks to dizzying heights using structures made entirely of wood. With the foundation ready, the most spectacular stage began: the construction of the walls. This process was slow and methodical, requiring incredible precision. Each stone had to occupy its own strictly defined place in the masonry. The mason's main tool was a plumb line, a simple but indispensable device for checking the verticality of the walls. The plumb line was a cord with a weight at the end. With its help, the craftsman checked each row of masonry with millimeter precision. Various mechanisms were used to lift stones and mortar to a height. The simplest of these was a winch, a log with handles onto which a rope was wound. More complex structures were actual lifting cranes powered by muscle power. The most powerful lifting mechanism was the tread wheel. It was a huge wooden wheel inside which people walked, rotating it with their weight. Such a device allowed lifting stone blocks weighing several hundred kilograms. The working day in winter was short due to the lack of light. Work began at dawn and ended at dusk. Every minute of daylight was used with maximum efficiency. The masons worked on wooden scaffolding that grew upward along with the castle walls. This scaffolding was an independent engineering structure, strong and stable. It was assembled from logs, fastened with ropes or wooden pegs. Working at height in winter required special skill. The scaffolding platforms were regularly cleared of snow and ice to prevent falls. Despite all the difficulties, the process did not stop. The castle walls usually consisted of two outer layers of hewn stone. The space between them was filled with rubble, gravel, and poured with liquid mortar. This technology allowed for the construction of very thick and durable walls. Thus, row by row, the castle slowly grew upward. It was a picture of perseverance and skill, a daily victory of man over harsh conditions. Every stone laid in the wall was evidence of this titanic struggle. Are you ready for the shocking truth? Medieval carpenters did not spend all their time balancing at heights in the wind and snow. Most of their work was done right on the ground, in the warmth, under a roof, in huge workshops where the smell of fresh shavings mingled with the aroma of resin. Winter was their prime time. While the fields lay covered in snow and the earth slept, the carpenters turned the prepared tree trunks into the future bones and joints of the castle. While the masons slowly erected gray walls, work was in full swing in another world. The world of wood, the clang of axes, and the rhythmic squeak of saws. There, beams, trusses, frames, stairs, and doors were born. Everything that would give the stone giant's soul and comfort was created right here. It was not just woodworking. It was an art that required precision and iron patience. Each workshop was almost like a factory, only without machines. Under a long roof supported by powerful beams, dozens of carpenters worked side by side. Workbenches stood along the walls, stretched cords served as markings, and a hearth always smoked in the corner. To warm hands and dry resin, light penetrated through small windows, and soft steam from people's breath and heated wood hung in the air. The presence of covered and warm rooms was a salvation for the carpenters. In winter, they could work without fear of rain or wind, without fear that the wood would get wet and lose its shape. Here, they could spend hours honing corners, checking joints, and fitting parts. The craftsmen said that wood was more obedient in winter, as if it yielded to the hand, knowing that its destiny was to become part of something great. All the elements of the future castle were created not at random, but according to carefully calibrated drawings and templates. Each rafter joint and each beam had its own number, markings, and assembly directions. Sometimes symbols were carved into the wood, a kind of carpenter's language that only they understood. It was a prototype of modular construction. Everything was fitted in advance so that all that remained to be done on site was to assemble the finished parts, like a giant construction set. When the castle walls were raised to the required height, the moment of glory arrived for these wooden giants. Ready-made structures, trusses, beams, floors, were brought out of the workshops and slowly lifted up with the help of blocks, ropes, and lifting gates. The people standing below froze as they watched the multi-ton wooden structures hover above the walls. Each element had to fit perfectly into place without any misalignment. Otherwise, the entire structure could collapse. Particular attention was paid to the trusses, a true masterpiece of engineering of their time. These triangular structures had to withstand the weight of the roof, snow, wind, and time. They were assembled on the ground, checking each joint with wooden pins and wedges. Sometimes the carpenters argued for hours about how best to distribute the load. Experience was passed on not from books, but from hand to hand. When the truss was ready, the entire team carried it. People stood shoulder to shoulder, lifted it up, and placed it on the walls like a crown on the head of a castle. This required incredible coordination and strength. One wrong move could cost a week's worth of work. But when the structure fell into place, a cry of joy rolled across the site. Another step toward the completion of a great undertaking. The carpenter's tools were simple but perfectly designed. Each craftsman treasured his axe like a sacred object. Its shape, weight, and balance were tailored to his hand. The saws had different lengths and teeth for cross-cutting or rip-cutting. The adze helped to shape the log, and hardwood planes smoothed the surface. Drills and chisels allowed for the creation of complex locks and joints without a single nail. Everything was done conscientiously so that even after 100 years, the castle would not sag or creak. There was always a smithy next to the workshops. Blacksmiths were not just assistants, they were the carpenter's right-hand men. They sharpened tools, forged new blades, and repaired broken parts. Sometimes they even made metal templates or marks for marking wood for the carpenters. The union of wood and iron was the foundation of any construction. This gave rise to an amazing system. The parallel work of two worlds, stone and wood. Bricklayers raised walls and carpenters created everything that would bring these walls to life. Their lines of work ran parallel, only to come together in an instant in the finished building. This method of organization was the pinnacle of efficiency in its time. No fuss, no downtime, no waste. Winter gave carpenters not only peace and time to work, but also the best material. Frost-damaged wood was denser and drier, did not attract beetles, and warped less. Therefore, winter wood was used for load-bearing beams, roofs, and doorways. The craftsmen knew that such wood lives longer than a person. Sometimes trees were specially harvested several years before construction, dried under a canopy, and treated with resin and ash. This process was called killing the tree, a symbolic transition from the living world to the world of creation. Only after this could the trunk become part of the castle. The atmosphere in the workshops in winter was special. In the evening, when the wind howled outside the windows, the carpenters continued to work by torchlight. The sound of hammers and the creaking of wood created a special kind of music. People worked, joked, sang, and every line of the songs was filled with pride. After all, they were not just building a structure, but a symbol of strength and faith. Even the young apprentices, who were just learning to hold an axe, felt that they were participating in a great undertaking. The older masters told them stories about castles that had stood for hundreds of years, about roofs that had survived storms, and every apprentice dreamed that one day his mark on the wood would remain for eternity. In winter, carpentry became a science and an art. People created not just beams and trusses, they created the skeleton of the future fortress, its breath. And when the sun began to melt the snow in spring, and the first drops of water dripped from the roofs of the workshops, the carpenters came outside, ready to see their creation rise above the walls. What other elements of the castle, besides roofs and floors, do you think could have been made in advance? After all, staircases, galleries, bridges, and even defensive mechanisms were often assembled in these very workshops. In the next chapter, we will take a look inside these wooden temples of labor and find out exactly how they were arranged, and why no medieval castle could have been built without them.
Finest work we've done. It will stand for centuries.
The key to year-round construction was the creation of a work area protected from the weather. Medieval craftsmen understood perfectly well that even the most talented mason or carpenter could not work effectively in snow, rain, or piercing wind. Therefore, they perfected the art of building temporary covered workshops, special wooden shelters that allowed them to work in any weather. These structures were not just auxiliary, they became the heart of the entire construction process, without which the castle would never have risen from the ground. These were usually long, tall structures resembling barns or wooden hangars. The frame was assembled from thick logs fastened with pegs and wedges. The space between the beams was filled with boards and reeds, and the outside walls were often coated with a mixture of clay and straw for better insulation. The roofs were covered with thick straw or turf, which not only retained heat but also protected from rain. Sometimes the top was reinforced with boards to prevent the snow from destroying the roof under its weight. Inside such structures, there was a special atmosphere. It always smelled of smoke, resin, and fresh wood shavings. The air was warm and humid because several hearths or simple clay ovens burned from morning to night. Bricklayers and carpenters warmed themselves, dried their clothes, and at the same time dried their materials. After all, wood cracks in the cold, and lime mortar loses its properties. Working in relative warmth was of great importance. In workshops, it was possible to work with stone and wood with a precision that was unattainable in the open air. Even minor operations, such as carving ornaments or drilling holes for spikes, required a stable temperature. Fingers should not go numb, and metal tools should not be covered with frost. Carpenters occupied most of the interior space. They spread long ropes on the floor and drew markings for future beams, doorways, and rafters. Some templates took up the entire length of the workshop. After all, they were not building small houses, but giant castles with halls and towers. Working indoors allowed for perfect fitting of parts. Even a millimeter error could later prevent the truss from fitting into place. The strength of the joints was also tested here. Carpenters assembled individual components, tested them under load, and only then disassembled them and sent them to the site. Within the walls of the workshops, one could hear the clanging of hammers, the squeaking of saws, and the whistling of shavings, the continuous music of labor. The blacksmiths were not left out either. Their forges were located under sheds or in annexes to the main workshops. This is where nails, staples, locks, door hinges, chains, and shackles for gates were made. Without their products, construction would simply have come to a halt. Carpenters depended on blacksmiths just as much as blacksmiths depended on fire. Often, a box of coal stood next to the anvil, which was thrown in continuously to keep the flame from going out. Sometimes blacksmiths and carpenters worked together in the same workshop. This was convenient. They could immediately try on metal parts, check fasteners, or adjust hinges for a specific door. Such interaction made work much faster and more efficient. One of the main problems remained lighting. In winter, the days are short, and candles and torches provided too little light for precise work. Therefore, large openings were made in the walls, and especially in the roof. They were covered with oiled cloth, parchment, or dried ox bladders. These materials allowed soft, diffused light to pass through without letting in the cold wind. Sometimes the windows were closed with wooden shutters at night to keep the heat in. Inside, additional lamps were always lit. Oil lamps suspended from the beams. The flames swayed slightly in the drafts, casting lively shadows on the walls. This dim light made the atmosphere of the workshop almost mysterious, as if it were not just a craft but magic. But the workshop was not just a place of work. It was a real training center. Here, apprentices learned from the masters, watching their every move. The apprentices held the tools, handed them materials, wrote down measurements, and gradually mastered the secrets of the craft. It was believed that only winter work in the workshop could turn a novice into a true master. Over the years, entire dynasties of craftsmen emerged from such workshops. Sons continued their father's work, passing on their knowledge. There was a special hierarchy inside. The masters occupied the best places near the light and heat, while the apprentices sat closer to the walls where it was colder. But even the youngest understood that they were part of a great process in which every nail and every beam mattered. When the construction of the castle was nearing completion, the workshops gradually emptied. The fires in the furnaces went out, the tools were packed away in chests, and the people moved on to other projects. Often, the workshops themselves were dismantled. Their wood was used for flooring, roofs, fences, or simply as fuel. However, their role in construction had already been played. It was they that allowed the work to continue uninterrupted, regardless of frost and snow. The existence of such production centers proves that medieval construction was far from chaotic. It was a clearly organized process, where everything was subject to plan and discipline. Workshops, warehouses, smithies, and sawmills formed a unified system that anticipated the principles of future industrial production. This was the real secret of success, not only in the talent of the craftsmen, but also in the amazing organization of their work. In winter and summer, in heat and cold, work did not stop for a single day, and this is the main proof that medieval builders were not just craftsmen, but true engineers of their time. It would seem that the onset of spring should have brought relief, but for the builders, it brought new problems. The melting snow and thaw turned the construction site into a sea of mud. This time required a change of tactics and the solution of new problems. The main problem was the roads. The frozen winter roads, ideal for sleds, turned into impassable quagmires. Wheel carts got stuck in the mud, which seriously hampered the delivery of materials. During this period, they tried to use the stone and wood reserves accumulated over the winter. Work on the construction site switched to stages that did not require constant supplies. The craftsmen concentrated on interior finishing and the installation of ready-made structures. Melting snow posed a great danger. It could flood the pits and wash away the foundations of temporary structures. To combat this, drainage ditches were dug in advance to divert water away from the construction site. The ground, frozen over the winter, began to thaw and shift. This was the most critical moment for the foundation laid in winter. The builders closely monitored the condition of the masonry to notice any deformations in time. The spring thaw could practically isolate the construction site from the outside world for several weeks. That is why it was so important to create sufficient reserves of food and fodder during the winter. The construction site had to hold out on its own resources until the roads were restored. On the other hand, spring also opened up new opportunities. River navigation began again, allowing heavy loads to be transported over long distances. Work that was impossible to carry out in winter, such as preparing mortar in the usual way, resumed. Working on scaffolding during this period also became more difficult. Wet boards were slippery, and gusts of wind were strong. Increased caution and safety measures were required. Thus, each season dictated its own rules of the game. Medieval builders were masters of adaptation. They knew how to take advantage of each season and minimize its disadvantages. The end of the winter construction season was an important milestone. It meant that the most severe trials were behind them. A successfully survived winter was a guarantee that the castle would be completed on time. We can see that medieval builders were not just craftsmen, but true strategists and engineers. They did not submit to winter, but used its characteristics to their advantage. The secret of their success lay in careful planning, unique technologies, and the highest level of labor organization. From the creation of a temporary city to the alchemy of hot mortar, every aspect of their work was thought out to the smallest detail. It was a system in which there were no insignificant details. It was this approach that made it possible to erect grandiose structures that still amaze us today. The history of winter castle construction is a tribute to human ingenuity and perseverance. It teaches us that even in the harshest conditions, a solution can be found if we approach the task with intelligence and knowledge. These nameless masters of the past left us not only stone walls, but also a great lesson in resilience. Please suggest topics for future videos that you would like to see on our channel in the comments. Perhaps you are interested in the construction of cathedrals or the secrets of medieval bridges? Don't forget to subscribe so you don't miss out on new exciting journeys into the past.